This is a video on using the first derivative test to locate and classify relative extrema. The question states, identify all relative extrema of f of x equals x cubed minus 6x squared plus 9x minus 2. So relative extrema occur at critical points. So my first step is to find the derivative of f of x. And I get f prime of x equals 3x squared minus 12x plus 9. So to find the critical points, I set the derivative equal to 0 and solve. And I can factor this derivative. I can pull out a 3, and I get an x squared minus 4x plus 3. And then I can factor that, and I get 3 times x minus 1 times x minus 3. And I set that equal to 0 to find the critical points. And I get that x equals 1 or x equals 3. So now that I have the critical points, let's put them into a table and use the first derivative test to decide whether they're maximum or minimum. So here's a table. I start out with the interval from negative infinity to my first critical point, or 1, and then 1 to my second critical point, which is 3, and then 3 to infinity. And the next step is to pick a test value in each interval. In between negative infinity and 1 lies 0. In between 1 and 3 lies 2. And 4 is between 3 and infinity. So now I'm going to plug in these numbers into my first derivative to decide whether that first derivative is positive or negative. So if I plug in 0, I get 9, and that is a positive number. If I plug in 2, I get a negative number. Notice I can just plug into 3 times x minus 1 times x minus 3, and if I plug in 2, I get 3 times 1 times negative 1, and that's certainly negative. If I plug in 4, I get 3 times 3 times 1, and that's certainly positive. So now I can state my conclusion. If the derivative is positive, then the graph is increasing or points upwards. If the derivative is negative, the graph is decreasing or points downwards. And if the derivative is positive, again, it goes upwards. So I can see my graph goes up and down and up. So that means at 1, it had gone up and then down. So 1 is a relative maximum. At 3, it went down and up. So that means it's a relative minimum at 3. Now my final step is to just plug in the numbers into the original function to get my y values. If I plug in 1, I get 1 minus 6 plus 9 minus 2, and that's 2. And if I plug in 3, I get 27 minus 54 plus 27 minus 2, which is negative 2. So I can conclude that there is a relative maximum at the point 1, 2, and a relative minimum at the point 3, negative 2. And I'm done with the problem.